Welcome to Maths and Science by IITian channel. Now, I will be solving a question of JEE and Maths Olympiad level where it is asked to find the range of real solutions. The problem itself indicates that there are real solutions available for the equation. We have to find what are the real solutions and what is their range. The equation is x to the power of y cube minus x minus y to the power of x cube minus y is equal to ln x to the power of ln y cube minus x minus ln y to the power of ln x cube minus y. It looks a very tough question at the face value of it, but it's not that tough. It's a logarithmic exponential equation. Logarithm is there, to that exponents are also there in the logarithm. Logarithmic exponential equation. I have solved one of this type of question which is asked in JEE Advanced 2025 and in the previous lectures. You can refer to this logarithmic exponential equations. This particular equation is made by me for practice. It's a good question. We have to find the range of the real solutions. Let's proceed further. The given question is find real solutions, range for x to the power of y cube minus x minus y to the power of x cube minus y is equal to ln x to the power of ln y cube minus x minus ln y to the power of ln x cube minus y. This is the question. Now, we have to simplify the right hand side equation because right hand side is the complicated one. Left hand side is nothing but something to the power of something. But right hand side is logarithmic exponential. So, solution follows like this. Ln x to the power of ln y cube minus x. How to write it? It is in the form of p to the power of ln p to the power of some q. When your ln p to the power of some q can be written as q ln p. Do you agree? Ln p to the power of q is equal to q into ln p. This is from the basics of the logarithm. For example, ln 8 is equal to ln 2 to the power of 3 is equal to 3 into ln 2. Do you agree to this? What is the ln 8 value? 2.08. What is 3 into ln 2? 2 into 0.693. What is 3 into 0.693? Because ln 2 value we know. It is 2.079. If you make it round off, 2.08. That means ln x to the power of y or ln p to the power of q is equal to q into ln p. This basics I think you are all aware, but still I wanted to utilize this utility, this particular property, and solve this problem. Then right hand side becomes, right hand side is equal to, what it becomes? Because power is ln x to the power of ln y cube minus x. That will become ln y cube minus x into ln x minus ln x cube minus y. ln x cube minus y into ln y. Right hand side becomes like this. Now, for ln y cube minus x to exist, for ln y cube minus x to exist, because we are asked to find out the real solutions, y cube minus x should be greater than 0. Otherwise, negative algorithm does not have any meaning. Similarly, for ln x cube minus y to exist, that implies x cube minus y should be greater than 0. Both these are in the same equation, and these both should be simultaneously satisfied. It is not that one after the other, because both are there in the same equation. Both should be satisfied. This value should be positive, this value should be positive. X cube, y cube minus x should be positive, x cube minus y should be positive. Both should be greater than 0 simultaneously. When it will be possible? That is the question. The main crux of the problem is when y cube minus x is greater than 0 and x cube minus y is greater than 0 simultaneously. This will be possible only when, because of the similarities, you please check y cube minus x here, x cube minus y. This will be possible when x is equal to y. That implies x cube minus x is equal to greater than 0, or y cube minus y is greater than 0. That implies x cube minus x is x into x square minus 1 is greater than 0, or y into y minus y square minus 1 is greater than 0. Now we are required to find the range of x into x square minus 1 is greater than 0. In this should be positive and this should be positive. Both when positive only, they will be greater than 0. Or it should be negative and it should be negative. Then only either both should be positive or both should be negative. That implies x square minus 1 will be positive when x is greater than 1. X should be greater than 1. When x is greater than 1, automatically x is also positive. That means for this condition it is valid. And x square minus 1 will be negative when x is greater than x square minus 1 is negative when x is greater than minus 1 and less than 0. This will be negative when x is less than 0. And this will be negative when x is greater than minus 1. Hence, there are two ranges. One is x is greater than 1 and another is minus 1 is less than x less than 0. That means the solution is the solution for the range of real solutions for the given equations are x is greater than 1 or minus 1 is less than x less than 0. This is the solution, provided x is equal to y. Other than this, there is no range, and x is equal to y should be the first condition. When x is equal to y, x is greater than 1 or minus 1 is less than or equal to less than x, and x is less than 0. And this is what is the solution. If it is equal to minus 1 or equal to 0, it does not have any solution. Hence, this should be the condition under which if x is equal to y, this is the range of the real solutions. This is the answer. If there is a value addition to your knowledge because of this problem and solution, please subscribe to my channel and share this channel to others you know. Best of luck to everybody. Thank you for listening to me. Thank you for viewing my lecture.